Hello, this is a demonstration of calculating probabilities using the probability laws and Venn diagrams from the MEI S1 syllabus. I'm going to use Jan 2013 question 3 as an example. So just bear in mind again that MEI work on solving probability either by using Venn diagrams, probability trees, or combinations. And immediately you see some of these questions, you've got to work out which way you're going. So let's have a quick look at this one and see what tells us where to go with it. Okay, first thing we do is read the question. Each weekday, so let's get that going. Each weekday, Alan drives to work. On his journey, he goes over a level crossing. Sometimes he has to wait at the level crossing for a train to pass. Okay, W is the event that Alan has to wait. At the level crossing. L is the event that Alan is late for work. So these are two separate events going on here. You are given that probability L given W equals 0.4. Probability W is 0.07 and the probability of L union W is 0.08. The first thing it's going to ask us then is calculate the probability that L intersect W. So that's the combination of the two. It's the AND. Okay, so how are we going to go about this? Well, we've got two different events. They've given us these probabilities, and we can use the probability formulae from the tables. So let's get those up. So there are the formulae that we need to use. They're the classic formula, and that's the format in the formula book. So what they asked us to do, calculate the probability of L intersect W. Well, looking at our second formula there, which is what matches to what we're interested in, that would be the probability of L times the probability of W given L, or we can turn it the other way around and we can do the probability of W times the probability of L given W. So those are the two interpretations you can use of that, and we're going to pick up the second one there. Because why are we going to use that one? Because they've given us probability W and they've given us the probability of L given W. So that's the probability that probably the L will happen given that W has happened. So we can just punch the numbers into in here and give ourselves a very quick answer, 0.28. And bear in mind that they would usually be looking for us to do all our work to three significant figures, but here our final figure is going to be 0. Okay, so look at the next part. Draw a Venn diagram. So that's told us very clearly, reconfirmed that we're on the right track. We had to use the formula of the first one. Now we're going to turn the information we've got above into a Venn diagram because it's showing the events L and W. And it says fill in the probability corresponding to each of the 4 regions. Okay, so let's see what we already know then. So we're going to draw our diagram. Always remember on these, so we're going to draw our 2 circles. So our start position, we're going to give them each a letter. So L's going to be for the left hand one, W is going to be for the right hand one. So that's our standardized Venn diagram. And now we can go through and start filling in our figures. Well, we've just worked out that the intersection of L and W has got probability of 0.028. So that was our point from there. We also know from earlier that PW equals, let's just get that one down, 0.07. So therefore it means that we can work out very quickly the probability. Let's whiz up, give ourselves some more space. So therefore we can very quickly work out the probability of W intersection with not L. That's going to be R 0.07 minus 0.028. And what other piece of information did they give us? They gave us the union, didn't they? Which we haven't used yet, the union of W and L. And given we just calculated the figure above, which was 0.042, we know the total is that. Then we know that the probability of L intersect with not W, well, we're going to use our other formula, aren't we, which is the probability that's but first we're just going to write it out. So that's going to be the probability of L, take away the probability of L intersects W, which we've already worked out. Yeah, so they give that's what we're going to try and find out now. And playing with the formulae, let's save time, shall we? The probability of L union with W is going to be equal the probability of L intersect with not W plus the probability of L intersect with W, so that's the bit in the middle, plus the probability of not L intersect with W, which we've already found, haven't we, above. So in our world, life is actually, just look at the diagram, pretty straightforward, isn't it? Because we know that the total area here, let's just go around it quickly. We know they've told us what that total area is there. That's the 0.808, isn't it? So here we've got a very simple one. So it's going to be 0.08 minus the two numbers we already know, 0.28 and 0.042, which equals 0.08 minus 0.07. We're just undoing what we did earlier. So that one's going to be 0.01. And how much is the outside going to be? Well, we know that it's going to be 1 minus. So probability of not L intersect with not W is going to be 1 minus probability of L union with W. So that's our 1.0 minus our, we were told that 0.08, which equals 0.92. So that's going to be our outside figure, 0.92. It is interesting, isn't it, that our friends at MEI like this approach, because in some ways that would be easier to do with a two-way table, wouldn't it? Where you'd be able to verify that all the figures add up to 1 as we went along. Here it is, and you can quickly calculate all the figures starting with the green ones and working your way out. Okay, what's the next thing they asked us for in this question? They asked us to draw it and calculate the regions, so that just leaves us with the final part. Determine whether the events L and W are independent, explaining your method clearly. Okay, let's have a think about different ways of explaining this. Well, there are basically two ways of demonstrating independence, and it depends on independence or not. And I'd start with one of two criteria. we'd either have probability that A given B, if they're independent, well, whatever happens with B is irrelevant, so that would just be probability A. And your other option is the probability A intersect B, and that's the and in effect, would be probability of A times the probability of B, if they're independent, yeah? So here, which one are we going to use? Let's quickly go back up and see which information they gave us earlier and which one best fits. Well, looks like we've now got enough information to go either way here. So let's pick one out because we've calculated all the figures. So what we could do is we've got probability of L given W. Does that equal to probability of L? Well, we know probability of L given W. They gave us that in the question, didn't they? Up the top here was 0.4. 0.4. And what have we worked out for the probability of L? Well, the probability of L, which we've got that, which we could calculate from our Venn diagram, would be this area here. So let's draw around it. That's our probability of L. So that's 0.01 and 0.028. So we've got 0.01 plus 0.028. So that side would equal 0.038, not 0. Sorry, I think I wrote it's actually 0.04, isn't it? Yeah, no, it's 0.4. Well, they're not equal. So that would be a very quick way of checking that out. Our other way would be, if you had different information, would be to find LW, L intersect W, and whether that equals probability of L times probability of W. And these are your two fundamentals. So probability L, probability intersect W, we worked out earlier was 0.28, 0.028, and that does not equal the probability of L, which we worked out, and we've just worked out there, is 0.038 times the probability of W, which they gave us at the top, is 0.07. So if we just calculate those out, we get, which equals 0.00267. Here we go. Oh, that's not as clear as it could be. There we go. So what's our conclusion now? Therefore, L and W are not independent. So one of those should be true. Just write that to make that clear, if independent. Okay, here we are. Okay, here's my quick summary at the end. Just look at the question. If the question does not state that events are independent, then use the probability laws and tables to calculate your figures, create a Venn diagram using those laws and complete it. And if two events are independent, then we can use one of these two things that should be true if they are independent to test that. So probability A given B, if A is independent, B should just be the probability of A. And the probability of A intersect B, if they're independent, should just be the probability of A times the probability of B. So you can test those and you can reach your conclusion. I hope that's useful. Bye.